Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you an example of how you can do a hypothesis testing for the population mean. Well, based on the example stated here, it says that the previous study reported that the average salary of IT executives is at most 42,000 ringgit Malaysia. A sample of 30 IT executives has a mean salary of 43,000 ringgit 260. And at alpha 0.05, test the claim that IT executives earn more than 42,000 ringgit a year. Assume the population is normal, and the population standard deviation is known, which is 5,230 ringgit. Okay, so now we are going to translate all these words into mathematical symbols. So here, when you talk about average salary based on the previous study, this will represent the value of mu. So this will become your null hypothesis. Okay, so this statement here refers to the statement of null hypothesis. And when you talk about at most, the mathematical symbol will be less than or equal to, because the value can reach at most 42,000 ringgit, or it's going less than that. Okay. Next, the sample of 30 IT executives. So this is n equals to 30. The mean salary 43,000 ringgit 260. So here refers to x bar. Okay, so you can see the difference between mu and x bar. X bar here represents the mean for the sample. Now alpha 0.05, so alpha here is the significance level, and then you're going to test the claim that the IT executives earn more than 42,000. So more than means the symbol is greater than. So this statement here represents the alternative hypothesis. So assume the population is normal and that population standard deviation, so this is the value of sigma. So sigma is known and the value is 5,230 ringgit. And this sentence indicates that you should be using the formula that uses standard normal distribution table. Okay, so let's look at the first step. So I'm going to apply the traditional approach. So the first step is going to be stating the null hypothesis and alternative hypothesis. Okay, so first one is H null is equal to mu. So mu is less than or equal to 42,000 ringgit. Okay, so that is the null hypothesis statement. And then we are going to test the claim that IT executives earn more than 42,000 ringgit. So this will be the alternative, mu greater than 42,000 ringgit. And we know that based on this statement here, this is going to be a one-sided hypothesis. Okay, right. So the second step is going to calculate the test statistic. So the test statistic is going to be, we're going to consider z is equal to x bar minus mu over sigma, and here is the square root of n. Okay, so why are we considering this? This is because we have this information here which says that standard deviation is known, so sigma is known, so we are going to use this statistical test. Now we're just going to substitute the values. So x bar is 43,260 minus 42,000. So mu here is the value of null hypothesis. We know that mu can be substituted with 42,000 because here there is a statement of equality. Mu is equal to 42,000. So you can substitute that into here. So this value will be substituted into this position over here. Next, sigma is going to be 5,230 over the square root of sample size, and sample size is equal to 30. So if you punch in the values into your calculator, you will see that the value of Z statistic is going to be equal to 1.32. So this is using 2 decimal places. Okay, so next. So the third step. The third step is we are going to refer, or we're going to sketch the critical region for this example given here. So the critical region here depends on the value of alpha, which is 0.05, and it also depends on whether it is one-sided or two-sided. So this is a one-sided hypothesis, and the direction is towards the right because here is greater than, the symbol used is greater than, so we know that the critical region is going to be on the right side. So this is the critical region. This is the middle point is 0.0, and the area of this critical region is going to be equal to the significance level, which is 0.05. And based on this critical region, you need to find what is the critical value. So CV here represents the critical value. So you can refer to the standard normal distribution tables. Okay, let's say you refer to table 3b. In this standard normal distribution table, in order to use this table, you need to know what's the area on the right of the distribution. So remember what we are looking to find. We are looking to find what is the critical value, okay, for this area, where the area that we are looking to find here is equal to 0.05. Okay, so here is 0.05. So you want to find what is the critical value, or what is the point here on the horizontal axis. So this is the horizontal axis. Okay, so you want to find what is the point here that corresponds to the area of 0.05. Well, 0.05 is the area, so the area has to be found by referring to the inside of this table. So now we're going to find where is 0.05, and you will see that 0.05 is going to be in between these two values here. Okay, both values here are equally close to 0.05, so you can just choose either one of these. You can choose either 1.64 or 1.65, it doesn't matter. So let's say I choose this point to be 1.64. Okay, 1.64. Right, so that is the critical value. So therefore, based on this, the critical value is equal to 1.64. Okay, so now the fourth step. The fourth step is to decide whether you will reject or accept the null hypothesis. And that will be based by comparing the value that you have on the second step with the critical value. So if you look at this value here, 1.32, the position of this value is going to be somewhere here because this is a positive value, yeah, so it started from 0 and the value here will get bigger and bigger as you move on to the right direction. So 1.32 you can assume to be somewhere here, 1.32, and because of that you can see that 1.32 here doesn't fall into the critical region. So this is the critical region and the value here is not inside the critical region. Therefore, we say that unable to reject the null hypothesis because the test statistic 1.32 doesn't fall into the critical region. Okay, and based on that, okay, we are going to come up with a conclusion. So the fifth step is going to conclude the whole process. So we can say that because we are unable to reject H null, that means when you are writing down the conclusion, always remember to relate the writing with the alternative statement. Okay, so this is the alternative statement, and since you are unable to reject H null, that means this alternative statement is not supported, right? So therefore what we can say is, we can say that there is no enough evidence to say that this alternative statement is true. Okay, so there is no enough evidence to say that the IT executives earn more than RM 42,000 a year. Okay, alright, I think that's all for now. Thank you very much for watching.